There's a system of three particles. As you can see, their velocities are indicated. You have to calculate the velocity of their center of mass. The formula is summation of mi vi vector divided by summation of mi. Okay, basically m1 v1 plus m2 v2. How many ever particles are there? You have to add the momentum of all those particles. In this case, there are only three. Plus m3 v3 divided by m1 plus m2 plus m3. Okay, solve this quickly, all of you. I got one answer as minus 2 by 5 I cap plus 2 by 5 J cap. We'll see. Others also solve it quickly. Just substitute the masses and their corresponding velocities. I got another answer as minus 2 by 5 I cap plus 2 J cap. We'll see. Okay, whole divided by 5. Fine, fine. So minus 2 by 5 I cap plus 2 by 5 J cap. Okay. Right, so all you have to do is substitute those masses and velocities. First mass, let's assume it is the mass of the particle A, 2 kg. Rishi, can you tell me the velocity of A as a vector?
J cap, sir. Just
One,
one J.
1 J cap. Okay. 1 meter per second in the y direction. So 1 J cap. Plus second mass will take as B. That is also 2 kg. Yusuf, can you tell B's velocity as a vector in terms of I cap, J cap?
So minus J cap.
No, no, no. Left side is indicated by which symbol?
So minus I cap.
And how much is its magnitude? 2. So it will be minus 2 I cap. Okay, that is the velocity of the particle B. Then the particle C, its mass is 1 kg, 2 meter per second in the positive x direction. So 2 I cap divided by total mass of the system is 5 kg. That's all. Now 2 I cap minus 4 I cap effectively becomes minus 2 I cap. And there is another plus 2 J cap, all divided by 5. So you can divide by 5 on both sides. I mean, both terms. That's all. This is the velocity of center of mass. Okay. So we are just getting used to calculating the velocity of center of mass. That's all. Position and velocity. Okay. Now consider a situation like this. Let's say there are two particles. One of mass m1, the other of mass m2, separated by a distance d. So it's a system of two particles. Definitely there will be a center of mass for this system. You have to find out where the center of mass lies. Okay. For that, what we will do is we'll assume the line along which these particles lie is the x-axis, or any axis you can take. I'm assuming it is the x-axis. We want to know where the center of mass lies. Okay. Let's assume m1 is at the origin. If that is 0 origin, then the x coordinate of m2, like I can write x1 is equal to 0, x2, x coordinate of the second particle becomes d. So we know their masses, we know their positions. So solve this quickly, all of you. Like if the particles are lying on the x-axis, it means their y coordinates are 0, z coordinates are also zeros. Okay. Now if corresponding particles y coordinates are zeros, then from what we discussed yesterday, or basically from the definition of center of mass itself, you can say, if all the y coordinates are zeros, then the y coordinate of center of mass will also be 0. Similarly, if all the z coordinates are zeros, then z coordinate of center of mass also will be 0. What does this mean? This means if particles lie on the x-axis, only on the x-axis, none of them has any y coordinate or z coordinate. If all particles lie only on the x-axis, then the center of mass also will lie on the x-axis itself. Okay. So we can use that idea here. These two particles m1, m2 are lying on the x-axis. So their center of mass also will be somewhere on the x-axis itself. So all I want you to do is calculate the x coordinate of their center of mass. Do this quickly, all of you. I'll write the formula here. X coordinate of center of mass if you want. It is the summation of mi xi divided by the summation of their masses. Make it fast. Okay, Vanilla, your answer is correct only. Pawan, tell me, how are you trying to solve this? Or, okay, the formula is given to you.
Sir, answer వచ్చింది సార్ టైప్ చేస్తుంది.
Tell, you can unmute and tell.
Okay, m2d by m1 plus m2.
Okay, fine. So since there are only two particles, you can calculate the x coordinate of center of mass like this: m1 x1 plus m2 x2 divided by m1 plus m2. Now m1 is m1 itself. X coordinate of the first particle is 0. m2, x coordinate of the second particle is d, divided by m1 plus m2. Effectively, this becomes m2d by m1 plus m2. Okay, listen. Observe this carefully, all of you. D is the distance between the two particles. Fine. And we find that their center of mass will be at a distance, the x coordinate of their center of mass is m2d by m1 plus m2. Now observe that answer, the result. If you take d aside, it is m2 by m1 plus m2. m2 in the numerator, m1 plus m2 in the denominator. Denominator is more than the numerator. So the fraction is less than d. That means the answer is some value less than d. Less than d means center of mass will be somewhere between these two particles. Not exactly between them, but somewhere between them. And we got the x coordinate as m2d by m1 plus m2. That means this distance is m2d by m1 plus m2. Which distance? From m1 to the center of mass, the distance is m2d by m1 plus m2. Okay. Then how much will the distance on the other side be? D minus this. From D, if you subtract m2d by m1 plus m2, you will be getting m1d by m1 plus m2. That's the distance of center of mass from that side. Okay, so that cross represents the center of mass. I'll write it as C. Now observe the ratio of these two distances. Can one of you tell me the ratio of these two?
M2 by M1, sir.
M2 by M1 or M2 is to M1. The other terms will get cancelled. Okay, so center of mass divides the line joining M1 and M2 in the ratio M2 is to M1. Okay, it splits the line joining them in that ratio. Fine. Now some of you may be thinking, like, we took one of their x coordinates as 0. Maybe that is why we got this result. How can we say this is true in general? Okay, so let's solve one problem to clear that. We'll verify if it is true in general or not. Let's take some values now. Assume the mass m1 is 2 kg and let's say this mass is 4 kg and 2 kg is present at, let's say, okay, 1 second. Let's say it is at x is equal to 2 meters and the other one is at x is equal to 10 meters. Okay, let's take 11 meters. Fine. I want all of you to solve this. You know the masses, you know their positions. Calculate position of center of mass first. Make it fast. M1 x1 plus M2 x2 divided by M1 plus M2. Okay. Within 1 minute, all of you should type your answers. Simple calculation should not take that long. I got one answer as 9 by 2. 9 by 2 is not correct. Vanilla, Aishwarya, your answers are correct. Pawan, Yusuf, type your answers quickly. Pawan, how can you give two answers? A system can only have one center of mass. And if you substitute in M1 x1 plus M2 x2 by M1 plus M2, you'll get one answer only, no?
సార్ అంటే విత్ రెస్పెక్ట్ టు ఒకదానికి ఇంకో దానికి అలా రెండు కలిపి చెప్పాను సార్.
Tell me the position of center of mass. Where is it? You gave the distances. You use the formula M2d by M1 plus M2, M1d by M1 plus M2. But we are verifying whether that formula is true or not. So you have to use the original formula for position of center of mass. Use of any answer? Okay. If you substitute properly in the formula, x coordinate of center of mass is equal to m1 x1 plus m2 x2. There are only two particles, no? So m1 x1 plus m2 x2 by m1 plus m2. You will get the answer as 8 meters. Okay. That means x is equal. Okay, this one is at 2, one is at 11. The center of mass is at x is equal to 8 meters. Fine. Now 2 to 8 is 6 meters. And 8 to 11 is 3 meters. So the center of mass of these 2 points, or the center of mass of these 2 particles, is dividing the line joining them in the ratio 6 is to 3. That is the ratio 2 is to 1. is it same as the ratio? Like if you consider 2 kg as M1 and consider 4 kg as M2, how much is M2 is to M1? 2 is to 1 itself. Okay. So it is true in general that the center of mass of two particles, okay, lies on the line connecting the two particles, and it splits the line connecting them in the ratio M2 is to M1. Like from the side of M1, if you see, M2 is to M1 is the ratio. From the side of M2, if you see, then the ratio is M1 is to M2. Okay. So using this ratio, in many cases, you can directly tell where the center of mass is without doing all that calculation. Fine. So we can generalize this statement. The center of mass of any two particles lies on the line joining the two particles and divides it in the inverse ratio of masses. Okay. Now try to answer this directly by using this ratio. Okay. Suppose there are two masses like this. Assume one of them is 3 kg, the other is 4 kg. And the distance between them is 70 centimeters. Using the ratio, tell me how far is the center of mass from 3 kg? What is the distance of the center of mass from 3 kg? Okay, Pawan, Venala, your answers are correct. Rishi, tell me, in what ratio should the center of mass divide this line? Like from the side of 3 kg, if you see, in what ratio should the center of mass divide this line?
I'm not sure.
Okay, fine. Aishwarya, can you tell in what ratio the center of mass should divide the line joining them? If you consider this as M1, this as M2.
So 4:3.
It should divide the line joining them in the ratio M2 is to M1. So 4 is to 3. 4 parts on the left side, 3 parts on the right side. So it will be closer to the 4 kg mass. This will be the center of mass of this system. Okay. So you have to split 70 centimeters in the ratio 4 is to 3. Now listen, all of you. Some of you may not be very comfortable splitting it into the ratio, in splitting a certain number into a ratio. Now 70 centimeters, you have to split in the ratio 4 is to 3. Means you have to divide it into 7 parts first and put 4 parts on the left side, 3 parts on the right side. Now 70 centimeters, when you divide it into 7 parts, each part will be 10 centimeters. 4 of those you have to put on the left side. So on the left side, you will have 40 centimeters. 3 of those you put on the right side. So right side will be 30 centimeters. That is where the center of mass lies. Okay. So for a two particle, see why we are considering two particle system so much is because we will very frequently come across systems like this. Fine. As we progress through the chapter, you'll understand it's very common to find a pair of objects connected or pair of objects being part of a system. Fine. So for a pair of objects like this, the center of mass will divide the line joining them in the ratio M2 is to M1. You can easily or directly tell where the center of mass lies. Okay. Next, we know that the position of center of mass is given by this formula M1 R1 like first mass multiplied with the first mass's position vector plus second mass multiplied with its position vector, so on. The last mass multiplied with its position vector divided by the total mass of the system. Okay. Velocity, acceleration are also related in a similar manner. We can even relate displacement of center of mass in the same, we can even express displacement of center of mass in the same manner. M1 multiplied with displacement of the first mass plus M2 multiplied with displacement of the second mass, so on. Mn multiplied with displacement of the nth mass divided by the total mass of the system. That is the formula for displacement of center of mass. So if you know how much is the displacement of individual particles, you can tell how much is the displacement of center of mass. Or you can do it the other way also. Suppose you know the displacement of center of mass and all individual particles except one. That can be calculated using this formula. Okay, let's make use of this. Again, let's consider a two-particle system itself. Okay, let's say the masses are M1 and M2 itself. And you know they will have a center of mass somewhere along this line, dividing it in the ratio M2 is to M1. Now, you are told that M1 is displaced to the right by a distance S1. Okay. How much should M2 get displaced such that the center of mass remains stationary? Okay. Derive displacement of M2 such that the center of mass does not get displaced. Try. M1's displacement is known to us. We have to find out M2's displacement such that center of mass stays there itself, where it was originally present before the displacements. Okay, Vanilla, your answer is correct only. You know the displacement of one of the masses. You should find out the displacement of the other mass such that center of mass does not undergo any displacement. Okay. Let us visualize first. Now see, if there are two masses like this, their center of mass will lie somewhere on the line connecting them, and it will be dividing the line connecting them in the ratio M2 is to M1. It has to maintain that ratio. Okay. Now, one of you tell me, If we keep M2 there itself, but shift M1 to the right side, okay, power neutral, M2 stays there itself, M1 moves to the right side, means M1 comes closer to M2. What should happen to center of mass? Will it stay where it was originally? Will it shift to the right or will it shift to the left?
సార్ హెవీ మాస్ ఎటు రైట్ షిఫ్ట్ అవుతుంది సార్
ఇది మరి బాగుంది.
మాస్
What you are saying is something different. That's not what I asked. You are saying where the center of mass lies. Center of mass always is closer to the heavier mass. We still haven't discussed that point, but that you are saying that. And suppose this mass is 10 kg. This mass is 2 kg. Center of mass will be closer to 10 kg. That is okay, but that's not what I'm asking. If 10 kg moves to the right side, which way will the center of mass move? Is what I'm asking.
టువర్డ్స్ M1
Towards?
M1
Means towards left.
yes sir
Okay. So Pawan is saying it will move to the left, means the center of mass should be somewhere on this side now. Let's assume it is like that. Vanilla, what do you say?
It moves to the left, sir.
Okay, so same answer. Rishi, what do you say? Which way will the center of mass shift?
Sir, ideally it should be moving to the left.
What ideal? Why should it ideally move to the left?
Sir, because not the length on the between M1 and C is more in the initial case, and when M1 moves towards the right, it will automatically move towards the left, sir.
Why?
Sir, I'm not sure about the logic. Like that's what I felt.
But you have to use your knowledge about center of mass, no? We discussed a few things about center of mass. In fact, today itself we derived how center of mass divides the line connecting two objects. Okay. Now see, if you assume their masses are 10 kg and 2 kg, then Pawan, you tell me in what ratio should the center of mass divide the line joining them?
1:5
2:10, that is 1:5. Means it will be somewhere here. Okay. From M1, the ratio should be 1:5. So if this is x, this will be 5x. That is how the center of mass divides them. And it so happens that the center of mass, by definition, is always closer to the heavier mass. Okay, here in this case, it is closer to 10 kg. You'll always see it being like that. That is like from the basic formula, it always comes out to be like that. Okay, wait, let me show the earlier position itself, just to avoid confusion. 1 second. Let's say this side is 2 kg, that side is 10 kg. Now then you will change your answer. Anyway, you said it will shift to the left. It should never, before giving these masses only, you said it will shift to the left. So your answer should not depend on what masses I take. So I see more distance on the left side, less distance on the right side. So I'll assume this is 2 kg and this is 3 kg. So the center of mass is dividing the line joining them in the ratio 3:2. Reasonable. Now, even if it moves, this mass will still be 2 kg only. And this will still be 3 kg. Their center of mass should still be dividing them in the ratio 3:2 only, no? Then if it divides them in the ratio 3:2, 3 parts on this side, 2 parts on this side, the center of mass should now be here. Why will it shift to the left? Okay. If one mass moves to the right side, center of mass also moves to the right side only. Because it should still be dividing the line joining them in the same ratio. It should maintain that ratio. Okay, if they come even closer, see, this visualization is important. That's why I didn't start solving the problem mathematically. Okay, you should first imagine how the center of mass moves. If they come even closer, even now the center of mass should maintain that ratio between the two masses. So again 3:2. It moves further to the right. One of the masses is not moving, no, only other mass is moving. Okay, so that point which divides them in the ratio 3:2 should also move to the right side. Otherwise, how will it maintain that ratio? Okay, is this clear to all of you or not? There's no rule that simply because one mass is moving to the right, center of mass should move to the left. Who told you any rule like that? There's nothing like that. Okay, center of mass maintains that ratio. That is from definition. From basic calculations, we can tell that it should maintain that ratio. So accordingly, you will tell whether it will shift to the right side or the left side. See, you can't use your own logics. Fine. There is a proper definition to center of mass. There is a proper behavior of center of mass, no? Well-defined behavior. Keeping that in mind, you have to give your answer. Okay, I'm telling this to all of you. This was not a random question I asked out of nowhere. I was expecting an answer based on what we learnt about center of mass. And what we learnt about center of mass today is that it should divide the line joining them in a fixed ratio. Inverse ratio of their masses, m2 is to m1. So it should always maintain that ratio between them. Is this clear to all of you? Any doubt in this? Okay. So if one mass moves to the right side, center of mass will move to the right. A little bit it has moved. If you don't want the center of mass to move, okay, means suppose you want to keep the center of mass at this position itself. Aishwarya, tell me what should be done? M1 has moved to the right, but we want the center of mass to stay where it was originally. Then what should we do?
Sir, M2 should be moved towards the left.
M2 should be moved to the left, correct. Because that ratio has to be maintained. One side, if the distance is decreasing, to maintain the same ratio, on the other side also the distance has to decrease. Okay, so if M2 moves to the left, then due to that, the center of mass will move a little bit to the left, and finally it will stay where it was originally. Same in the third case also. M1 moved all the way from here to here. Then M2 will have to move all the way from here to maybe somewhere here, such that the center of mass stays where it was originally, maintaining that ratio. Okay, due to M1's motion, center of mass went from here to here. Due to M2's motion, center of mass should come back from here to here and stay at its original place. Fine. So what you need to understand from all this is, if the center of mass is staying where it is, but one mass is coming closer, then automatically the other mass also must have been coming closer. Only then the center of mass can stay there itself. It can happen in reverse also. Suppose the center of mass is somewhere and one mass goes away from it. For the center of mass to stay at the same place, the other mass also will have to go away from it. Only then the ratio will be maintained, M2 is to M1. Okay, this kind of imagination is very important. Right. Now solve this problem, all of you. Vanilla has given an answer that is correct only. So what were you asked to find out? If M1 undergoes a displacement like this, we called it as S1. How much is the displacement of M2 such that center of mass does not get displaced? So S1 is known to us. S2 is what you have to derive. Tell me, have we discussed any formula involving displacements of particles and center of mass today? Have we discussed any formula involving the displacements of particles of the system and the center of mass of the system?
Yes, sir.
What is the formula?
M1S1 plus M2S2 by M1 plus M2 equal to displacement of center of mass.
Correct. That's all. You have to make use of that. Displacement of center of mass is M1 multiplied with displacement of the first mass plus M2 multiplied with displacement of the second mass divided by M1 plus M2. Now in this problem, you are given S1. You are given displacement of center of mass also. Center of mass does not get displaced, means displacement of center of mass is 0. That is also known to us. You have to calculate displacement of the second mass. How difficult is this? Do it, all of you. Make it fast. Center of mass is not getting displaced, means displacement of center of mass is 0. Based on that, you derive S2. Whenever you have an answer, just unmute and tell. You don't have to type. It may be difficult to type. Okay, Pawan, your answer is okay. Use of any answer? Okay, I'll not ask you anymore. Ask you for any more answers in this class, but Yusuf, make sure you go through the last 2 lectures. The recordings, I'll share the link to you. Rishi?
Sir, 1 minute, I'm still solving. Just a minute.
Okay, okay. Fine. You get 0 is equal to M1S1 plus M2S2 by M1 plus M2. So you can send the M1 plus M2 this side, it will become 0. It will get multiplied and become 0. That means M2S2 is negative of M1S1. That's all. So displacement of the second particle is minus M1S1 by M2. Okay. You can also write it like this. Displacement of first particle divided by displacement of second particle, S1 by S2, will be M2 by M1. Okay, this is another interesting result. Their displacements, okay, see, for what are we deriving the condition? Such that center of mass does not get displaced. That is what we are discussing now. So for the center of mass to not get displaced, their individual displacements should be in the ratio M1 by M2 with a negative sign, meaning they should be opposite to each other. Wait, I said M1 by M2. It is M2 by M1 with a negative sign, meaning they should be opposite to each other. So center of mass splits the line joining them in the ratio M2 is to M1. And if you want the center of mass to stay there itself, but the masses should move, then their movements also should be in the ratio M2 is to M1. Then the center of mass will stay there itself. And their movement should be in the opposite direction. Means if one is moving to the right, the other should be moving to the left. If one is moving to the left, the other should be moving to the right. Okay. Try another question. Suppose one particle of mass 2 kg is at x1 is equal to 10 and another particle of mass 3 kg is at x coordinate 4, where should a third mass of 1 kg be placed such that their center of mass is at the origin? Try. Two particles positions are given to you. Center of mass position is also given to you. Find out position of the third particle. I got one answer as minus 32. We'll see. Okay. Rishi, which formula should be used?
Sir, M1 X1 plus M2 X2 plus
Good,
M3.
good. Okay. Did you not get any answer?
I'm solving, sir. Just a minute.
Fine. XCM is M1 X1 plus M2 X2 plus M3 X3. How many ever particles are there? You have to add all of them divided by M1 plus M2 plus M3. Now you are given that the center of mass is at the origin. First mass is 2 kg, its x coordinate is 10. Second mass is 3 kg, its x coordinate is 4. Third mass is 1 kg, we don't know its x coordinate. Divide by total mass doesn't matter. It will go to the other side and get multiplied and become 0. So you can say 20 plus 3 fourths is 12. 32 plus x3 is equal to 0. So x3 is minus 32 meters. So that is where you should place the third particle such that the center of mass of the whole system is at the origin. Okay, simple calculation. Okay, try this problem now. A two particle system again. Let's say, okay, let's say one mass is 2 kg, the other mass is 1 kg. Their center of mass will lie somewhere on the line joining them. Assume both of them are moving such that the center of mass stays at rest. Okay. Now, if the particles undergo a okay, if the particles move closer by, let's say, 9 centimeters, such that the center of mass does not move. Calculate the actual distances moved by each particle. Okay. They have some unknown separation between them. If you want, you can assume some separation initially. Does not matter. They move closer by 9 centimeter. Means both of them are moving. Finally, the separation between them is lesser than the initial separation by 9 centimeters. And it is also known that the center of mass did not shift. Then find out how much each one should have shifted. Okay. Vanilla, the sign of your answer should be opposite actually. They are moving closer. According to your, the sign of the answer that you gave, they are going away from each other. They're coming closer. So first one will be positive, second one will be negative. But wait. No. The answers are also not correct. Check once. Because if it is 9 and 18, then relatively it won't be 9. Relatively it will become 27. Like 9 to the left and 18 to the right, relatively they'll be far away by 27 centimeters. Okay, listen, all of you. Basically, you should get used to converting a given statement into mathematical form. Okay, listen carefully. The particles move closer by 9 centimeters. We don't know how much each one is moving, but ultimately they are closer by 9 centimeters compared to the initial distance between them. So you can take something like this. Center of mass is not moving. That is given to you. You know from the analysis that we did earlier that center of mass divides the line joining the two masses in the ratio. Like in this case, it is 1:2. It will be closer to the 2 kg mass. Okay, center of mass of two particles is always closer to the heavier mass. If the masses are equal, then the center of mass will be the midpoint. Otherwise, it won't be the midpoint. Okay, it splits them in the ratio 1:2. You know that if one mass comes closer, the other mass also will have to come closer itself for the center of mass to remain stationary. Okay? So this is what is happening. We don't know by what distances they have moved. But totally they have come closer by 9 centimeters. Means if this is x, this will be 9 minus x in magnitude. Only then the total separation will decrease by 9, no? And from the second problem that we solved, okay, for the center of mass to remain stationary, their displacements also should be in the ratio m2:m1. I told you that. Not I told you, we derived that. S1 by S2 should be m2 by m1. That's all. Totally, they should come closer by 9 centimeters. So that 9 has to be split in the ratio 1:2. So 3 centimeters on this side, 6 centimeters on this side. Simple. In opposite directions. One moves to the right, the other moves to the left. Ultimately, they'll come closer by 9 centimeters. So the 2 kg mass will reach somewhere here, and the 1 kg mass will reach somewhere here. So 2 kg has moved 3 centimeters, 1 kg has moved 6 centimeters. Totally, they are now closer by 9 centimeters. If you want to solve it mathematically, okay? So this is how you begin. You have to visualize the situation first. Never try to solve physics problems blindly by writing equations. Imagine, and based on what you're imagining, you have tried the equation. So they move closer such that center of mass does not move. You have learned something about it. Recollect that first. Okay. So suppose you forgot that ratio. Let it be. They are closer by 9 centimeters. Then one should have moved some distance. The other should have moved the remaining distance. So if one moves x, the other moves 9 minus x. Now let's convert this to equation. We know the displacement of individual particles. And we know the we don't know the displacement of individual particles. We know the displacement of center of mass. Okay, we have an equation. Displacement of center of mass is equal to m1 s1 plus m2 is 1 kg, second mass is 1 kg. Its displacement, if you write as a vector, okay, displacement is a vector quantity only, you can't change its nature. Magnitude is 9 minus x, but it is to the left. So you should take minus of 9 minus x divided by m1 plus m2. That doesn't matter, it will get cancelled. So you get 2x minus 9 minus of minus x is plus x is equal to 0. So 3x is equal to 9 means x is equal to 3 centimeters. And that is what we got before also. 3 centimeters here, 6 centimeters here. So imagine what is happening and then write an equation based on what is happening. Okay, if you have to get used to doing this, otherwise you can't solve most of the questions in final exams. Because see, some of you are trying for NEET, that's fine. But the others who want to become engineers have to do calculations. Fine, they have to, in fact, most of the engineering in future is going to be related, based on the use of computers, no, artificial intelligence, machine learning, whatever it is. Okay, or even if you want to make a software which designs something for you, you have to feed all these equations into that software. Fine, some of them will have built-in, but if you want to make something new, you will have to make the computer do all these calculations. You will have to make the app or software do all these calculations. So you should know how to convert a given situation into mathematical form. Fine. So get used to it. Only then you will be able to do solve problems easily. Fine. We'll stop it here for today. Let's quickly go through what we had discussed. First, one basic problem based on velocity of center of mass. Then the rest of the discussion was based on center of mass of a two-particle system. The first thing we found out was that the center of mass of a two-particle system always divides the two particles, line joining the two particles, in the inverse ratio of their masses. So from the side of m1, if you see it, the ratio is m2:m1. From m2 side, it is m1:m2. So for a two-particle system, you can easily tell where the center of mass is. And based on this ratio itself, we can tell that center of mass is always closer to the heavier mass. Okay. Then we talked about how the particles can move without the center of mass getting displaced. So they should both come closer to the center of mass or both go away from the center of mass. And in what ratio? Same ratio, m2 is to m1. Okay, that is what we learned from today's problems. Okay. Next class will be on Friday itself. And that class we will discuss how to find out the position of center of mass of a continuous mass distribution. Now, if there are separate particles like this, you will use m1x1 plus m2x2. How many ever particles are there, you will add and divide by total mass. But suppose there is an object like a ring or something, okay, rod, ring, sphere, cone, anything. Such objects have infinite number of particles. So we can't keep adding m1, x1, m2, x2 of all the particles and get the position of center of mass. Okay. There we use integration to find out position of center of mass. Next two classes are very important because next two classes, of course, the classes will be about center of mass, position of center of mass and all. But we will use or we will learn how to use integration, okay, to find out the position of center of mass of a continuous mass distribution like a rod or a ring or a cone and such systems. The ideas we use in that integration will be used in a lot of other situations also. Like in this chapter itself, there is something called moment of inertia. There's a quantity called moment of inertia. Okay. Now you all are aware of inertia. It's basically the tendency of an object to continue doing what it is doing. And we learned earlier that mass is the measure of inertia. Momentum is a measure of inertia of motion. Mass is measure of inertia of rest. Momentum is measure of inertia of motion. Now, in this chapter, we come across a new quantity called moment of inertia, which is basically rotational inertia. How much tendency an object has to continue its rotational motion without getting disturbed. Okay. So there also, the ideas which we use while deriving center of mass will be applicable. And not just in that case, many situations after this, in gravitation, we'll be using those ideas. In second year electrostatics, we'll be using those ideas. Okay. So basically what we'll be learning is how to split a system of continuous mass distribution into small particles and do the necessary calculations. Okay, fine. And Friday's class will be at usual time only, 7 to 8:30. Okay, thank you all. We'll continue on Friday.